Go. Go. What are you doing? Are you playing the trumpet? You gotta turn it around this way. Oh, nice try. Yeah, nice try. Go. Oh, you did it. Good job. Push the buttons. Good job. Okay, go with Papa. Bye-bye. Okay. Yes, Walker. Well, okay, I'm supposed to teach the students now, okay? I'm teaching them right now. Okay, students, hello. We're going to do a lesson on percentages real quick. Yeah, Walker? Yeah. We're going to do a lesson on percentages. So you're going to take notes. This is video notes on percentages. Okay, here we go. What does percent mean? Percent. Okay, let's break down the word. Per. The per part means part of. The per part means part of. Yes, Walker. Okay, and then the cent part, the cent, what do you think cent means? Cent means 100. Cent, like let's think about the words, let's think about the word, there's 100 cents in $1.
It's a what?
There's 100 years in
it's a light.
One
it's a light.
Century. It is a light. Check it out. It's a light. My son Walker is telling you there's a light. Okay, great. There's let's see. There's 100 legs in one centipede. I don't know how to spell centipede. In one centipede. Okay, you get the idea. Well, there's probably other words that start with that have cent in them that mean 100. So per means part of, cent means 100. So what is part of 100? Well, anything that you want to think about is part of 100. What are you doing, Walker? Go with Papa. Oh, you're jumping on the bed now. Walker, go with Papa. Go with Papa. Please go with Papa. Please. Jump. Go. Okay. Well, that's not working out. He likes beds. He likes to jump on the bed. Okay, so part of 100. You ever seen the percent sign? It kind of looks something like this. Well, if you ever like turned it sideways, it kind of looks something like this. And now it's like the division sign. Okay, so that's what we're doing with percentages. We're dividing the part divided by the whole times 100. And that's what are you trying to do? And that's what percent means, okay? So the percent is the part divided by the whole thing times 100% equals your percentage. So whenever you're trying to solve for percentage, this is the equation right here. Here's your percentage equation. Boom. The part divided by the whole equals 100%. Like, so for example, let's do this one right here. It's okay. I think students don't think it's fun. We'll find out. Okay, so here's an example. Bye, Walker. Bye, Papa. Here's an example. On a quiz, you receive 7 out of 10. So let's identify the parts of the equation. The equation that we wrote was part divided by whole times 100% equals your percentage. So on a quiz, if you receive 7 out of 10, which one's the part and which one's the whole? Well, the whole quiz was out of 10 points, and you received 7 points. So that's the part that goes in the top. So it's part divided by the whole times 100%, and that is what gives you your percentage. So what the numbers that we need to do are 7 divided by 10 times 100%, and that gives us 70%. 7 divided by 10 is the same thing as 70 divided by 100. Okay, and that's what percentage is. You know what? Maybe you should get a calculator just in case you don't know how to use a calculator. Here we go. Okay, so on a calculator, you do 7 divided by 10, and I push the equal sign. So 0.7, and then we multiply that times 100. My son is pissed off right now. He's screaming. I don't know if you can hear him in the background. 70 is our answer. 70%. Make sure you use the little percent sign. Next question, number 2. There are 40 cookies in a basket. There are 24 sugar and 16 oatmeal cookies. What percent are the sugar cookies? Okay, so now we have 3 numbers here. How can we identify? There's 3 different numbers. Well, I think you're going to have to read and look at the words in between the numbers in order to identify what is the part and what is the whole. Well, we have 40 total cookies because it says there are 40 cookies in the basket. There are 24 sugar cookies and 16 oatmeal cookies. So the question is, what percent are sugar cookies? So we want to know what percent are sugar cookies. So we are going to take sugar as the part, sugar cookies as the part, and divide it by the whole. So our work should look something like this. 24, and I'm actually going to ask you to put units after every single number. 24 SC stands for sugar cookies, divided by 40 total cookies. Okay, now we're going to take that and multiply by 100%, and that's going to give us our percentage as the answer. Okay, so we're going to do on the calculator 24 divided by 40 equals 0.6. 0.6. I wonder what percentage that's going to be. Let's multiply by 100. And it equals 60%. 60%. Okay, so this is the equation that you need to know for percentages in order to find out what a percentage is. Okay, now let's talk about the percent of atoms in molecules. This is important in chemistry because the percent of atoms in molecules determines that molecule's properties, like boiling point, melting point, its state of matter sometimes at the specific temperature, and it also can determine how people use that molecule to improve the quality of life for everybody. Okay, so H2O. Well, first let's identify that there are 2 elements in H2O. There are 2 elements in H2O. Let me zoom in a little bit. Oh, that's zooming out. Here we go. There are 2 elements in H2O, and they are hydrogen and oxygen. Hydrogen and oxygen. By the way, you need to be writing down all of this. These are supposed to go in your notes. I don't know if I already said that. Probably already did. Okay, there are 3 atoms, and they are 2 atoms of hydrogen and 1 atom of oxygen. Okay, so how can we figure out the percent of atoms in the molecule? Well, we need to take the part and divide it by the whole. So we know that there's a total of 3 atoms. 2 of those atoms are hydrogen, and 1 of those atoms is oxygen. So we need to do 2 different problems here to figure out the percent of all the atoms in the molecules. So let's do two hydrogens divided by 3 total atoms. Multiply by 100%, and that gives us our percentage on the calculator. 2 divided by 3 equals 0.66 times 100 equals 66.66. It keeps going. What I'd like you to do is round to the hundredths place. That means we want to always keep 2 places after the decimal. That's going to kind of be a rule for this class. 66.67%. If I round to the hundredths place, that means I'm keeping 2 places after the decimal. Okay. Now, percentages, since it's part of 100, always add up to 100%. Now, if it's not exactly perfect, it's okay. It's fine if it's not exactly perfect because we're rounding, right? We're rounding, so it might not be exactly perfect. So I can, since I know that percentages add up to 100, I know that the remainder is going to be oxygen, since oxygen is the only one that's left. So that's approximately going to be 33.33%. Or I can do the percentage equation, which is the part, one oxygen, that's an O for oxygen, divided by the whole, which is 3 atoms, multiply by 100%. And that gives us, I don't need to use a calculator because I know the percentages add up to 100, 33%. Okay, and we'll say that this is 66.67% hydrogen, and this is 33.33% oxygen. So very important that we put the units. So for example, I forgot to put the units up here in this problem. The units are 60% sugar cookies. Okay, important that you put the units. It's so important that I grade you on it, and I take off lots of points if you forget the units because they're very important in chemistry class. Okay, next example I'll give is of this one right here. This is methane. This is the gas that comes out of your stove, methane. And in methane, there is a total of 2 elements there. Those 2 elements are carbon and hydrogen. Would you look at that? Carbon and hydrogen. There are how many total atoms? I'll wait a moment to see if you can figure that out. Making sure we're still recording. Okay, yeah, we're still recording. Okay, there are 5 atoms. If you answered that, that's correct, is 5. Okay, and that's 1 carbon and 4 hydrogens. So what's going to be the percentage of atoms in this molecule? Well, I need to take the part and divide it by the whole. So we know that there's a total of 5 atoms. That's the whole. That's the whole part in your equation. And then we have the parts right here. 5 atoms are 1 carbon and 4 hydrogen. So let's start with the carbon. 1 carbon divided by 5A for atoms. And we're going to multiply that by 100%. And that's going to give us the percent for carbon. C for carbon in the end. Okay, and that percentage is, what's 1 divided by 5? Maybe some of you know how to do this in your head. You're allowed to use a calculator for this class. 1 divided by 5. I know the percentage. How can I figure out 1 divided by 5 percentage? Well, 1 divided by 5 is the same as 2 divided by 10, which is the same as 20 divided by 100. And since we're talking about percentages, we're talking about parts of 100. So I know in my head from doing simple math that 1 out of 5 is a 20%. So let's do that on the calculator. 1 divided by 5 equals multiplied by 100 equals 20%. Try and do that simple math in your head. So if 20% is carbon, how much percent is hydrogen? Well, again, percent means part of 100, like we talked about earlier. And that means the remainder percentage is going to be 80% hydrogen. Very cool. Okay, I'm going to go ahead and give you time to do these right here while I just figure out the answer on my calculator. Okay. So for this answer, it's 27.27% carbon. Keep putting the divided button. And it's going to be 72.73% hydrogen. Okay, so this is the difference between methane that comes out of your stove and propane that you use on the barbecue. Propane has a higher percentage of carbon than methane does. Well, what does that mean? Well, it actually means since it has a there's more carbon and there's more hydrogen. Since there's more stuff inside of one molecule, it means that when this gas gets heated up and the bonds break and it forms carbon dioxide and hydrogen, and excuse me, water vapor, it burns with a hotter, or releases more energy, which means it burns with a hotter temperature. So propane burns with a hotter temperature than methane, the stuff that comes out of your stove. Okay. Go ahead and pause the video if you need to. Do the last one, and I mean this one should be super easy. Pause the video. I mean, if you see it already, good for you. I could see already that there's 4 atoms, and 4 is easy because I grew up using quarters and dollars and stuff like that. So 1 nitrogen is going to be 25% out of the 4, and the rest is hydrogen. Okay, you can go ahead and do the formula to solve that problem if you like, or you could do it in your head. Okay, so there's that. The part divided by the whole is a percentage. That's what we're learning today. Okay, here's a few more practice problems, and they're getting a little more difficult, a little bit more about chemistry, perhaps, maybe, in a few practice problems. Okay, so as a reminder, percent means part of 100. Something is part of 100. And that means if you say you got that 70% on a test, that means you got 70 questions correct if the test were out of 100 questions. Well, what if the test is just out of 10 questions? How many questions you get correct? 7. That's right. So that's how percentages work, because if you take 7 divided by 10, which is 0.7, and you multiply by 100, then you get 70% right here, multiplied by 100%. Okay. The percentage equation that I gave to you was this equation right here. The part divided by the whole multiplied by 100% gives you your percentage. Okay, well, we could rearrange this equation to solve not just for percentage, but we can solve for the part, or we can solve for the whole. So we're going to rearrange this equation to solve for the part. We would just need to use some algebra skills, and here's a review of algebra right here. Where's my red pen? Let's use red pen. Okay, in algebra, in order to isolate a variable that you want, isolate means get it by itself on one side of the equation, you want to perform the opposite mathematical operations on the other parts of the equation. So right now in this equation, while we're solving for percentages, we just want to solve for the part. So what we can do is perform the opposite mathematical operations. So part is being divided by, or whole is being divided by part. And what we want to do is multiply by the whole on both sides of the equation. Okay, so percentage times whole. Okay, so now we can cancel out the whole on this side because it's on the top and the bottom, is on the numerator and denominator. And now we get the new equation that the part times 100% equals the percent times whole. Okay, so it basically turns out to be just this. The part equals percentage times whole. Well, why did I get rid of the 100? Because the bottom part of the percent sign is the 100. So we're dividing by 100 and multiplying by 100 on both sides of the equation, meaning they cancel each other out. So we're canceling that out, and we're canceling that out. Okay. Let's do a problem. See if we can solve for it. Okay. Here's a practice problem. You can pause and play to make sure you get it right, or you can listen and write it down. You scored 12 out of 20 on your quiz. 12 points out of 20 total points on your quiz. So when you read this, you need to start being able to understand what's the part and what's the whole. The question is, what is your percent? Well, that's an easy one. It's asking for percent. So which equation are we going to use? The new equation or the old equation? Since we're solving for percent, we're going to be using the equation that isolates percent on the one side of the equal sign, which is this equation right here. Part divided by the whole times 100% equals the percentage. Okay, so we had 12 out of 20 multiplied by 100% equals your percentage. We'll say points is our unit, points. So on the calculator, 12 divided by 20 equals times 100 equals, what does it say? 60. 60%. You want to get a higher score than that on the quiz. 12 out of 20 points is not that great. It's a D. It's a D letter grade. You want to get an A. Here's an extra points question. What's the lowest amount of points you need to get an A? We're going to move on to question number 2. You scored a 70% on the test yesterday. The test had 40 total questions. How many did you get correct? So what is it asking for here? What are we trying to solve for? We're trying to solve for how many questions did we get correct on this test. So did we get all of them correct? Did we get the whole 40 questions correct? No, we didn't. We only got part of the questions correct. In fact, we got 70% of the questions correct. So we're solving for the part. So we're going to be using our new equation, okay, which is part equals, we have part isolated on one side of the equation, the equal sign, part equals percent times whole. So what we've got to do is take our 40 questions, oops, that's a G, not a Q. Okay, 40 questions, and we're going to be putting that over the number 1, and we're going to multiply that by our percentage. And what is our percentage? 70. Now, percent means out of 100. So that's 70 out of 100 questions. Okay, so this is the number 1 right here. Just to we put this number 1 just to show that the 40 questions is in the numerator, not the denominator. Okay, so what we need to do, this is multiplication in between, is multiply across the numerator and divide by the denominator. So that's 40 times 70, and that answer divided by 100. So on the calculator, it's 40 times 70 equals, oh wow, it's a big number, divided by 100. And we get 28. Okay, 28 questions is the amount that we got correct on this test. If we got 70% and the test was out of 40 points. Next practice problem. You received 80% on a test and got 48 questions correct. Now it's asking us how many questions were on the test to begin with. Okay. So what is the question asking? How many questions were on the test total? So we have a few different things to think about. We're trying to figure out how many questions were on the test total. That's the whole part of the equation. That means we're solving for the whole part of the equation. In order to solve for the whole part of the equation, we perform a little bit of algebra. And what we can see that we need to do is we need to take, if we want to isolate whole by itself, we need to perform the opposite mathematical operations, remember? And since whole is being multiplied by percentage, we're going to divide by percentage on both sides of the equation so that it's equal on both sides of the equation. What that lets us know is we can cancel out percentages, and then we end up with this equation that looks like this. Whole equals the part divided by percentage. Okay, let's see what that looks like down here. That's the equation we're going to need to use. Okay, so how I want you to show your work looks like this. We got 48 questions correct. That QC is important. We're going to put that QC over the number 1. And I'll just make it a normal number 1 so I'm not confused. To show that it's in the numerator, the 48 questions correct is in the numerator. And then we're going to be dividing by percentage. So how do we divide by percentage? Is we multiply by the inverse of what the percentage is. We got 80% on the test. Remember, percentage means part of 100. So that means we got 80. If the test were out of 100 points, we got 80 questions correct. The QC is for 80 questions correct out of 100 total questions. Okay, this is important to know because what we can do here is we can cancel out the QC on the top and the bottom of the numerator, and we're left with the unit that our answer is supposed to be in. This becomes incredibly important later in chemistry, and you might be thinking, why do I have to do that? Well, because it becomes incredibly important later in chemistry when we do stoichiometry and dimensional analysis. That actually means I can go back up here and change my units to this question. So really, my unit for this answer should be questions correct, because that's what it's asking for in this top question. How many questions did you get correct? Okay, so we do this 48 times 100. 48 times 100 divided by 80 is going to be 60 questions. Did I do that right on the calculator? So how do I do this on the calculator? You need to start with the number that you start with and multiply across the numerator and divide by the denominator after you get that answer. So it's 48 times 100 equals 4,800 divided by 100. There you go. And that's 48. Oh, excuse me. That's, oh, I did that wrong. 48 times 100 divided by, oh, I need to divide by 80. My fault. Divide by 80. And that's, oh, I did the math wrong. Sorry, one more time. 48 times 100 divided by 8. Oh, dang, keep looking at the number. Divided by 80 is 60. There you go. There's the answer, 60. Okay, so there's some good examples of how to rearrange the percent formula. So you can solve for percentage. So you can solve for the part, and you can solve for the whole. Okay, so here's an example of a problem that is doing mass percent, which basically means you're solving for the percent by mass. So earlier in our other examples, we were talking about just counting percentage, like the amount of points on a test, the amount of atoms in a compound, and we were figuring out the percentage by counting. Now we're figuring out the percentage by mass, and we call it mass percent in chemistry. So I'm just going to let you go ahead and read this. You can pause the video, try to answer the question. I'm about to give the answer, so pause the video. Okay, here's the answer. Okay, here's the next question. Something that you need to know is water's density. Water's density is for every 1 gram of water, that's the same as 1 milliliter of water. So a lot of things getting thrown around here that you might not know yet. G means gram. ML written like this means milliliter. H2O is water, and this is an equal sign in between. 1 gram of water equals 1 milliliter of water. Density is a topic we'll talk about later, but for now, this is the math that you need to know. Okay, so how do we solve this problem? Without giving you the answer, let me, oh, dang it, I probably just gave you the answer, whatever. Okay, so 200 gram solution of alcohol contains 180 milliliters of water. What is the mass percent of the alcohol? Okay, so we're pausing. You can pause the video right now if you'd like to. Okay, so it's a whole solution, 200 gram solution of alcohol contains 180 milliliters of water. So since there are 1 gram of water equals 1 milliliter of H2O, 180 milliliters of water equals 180 grams. So that means 180 grams of this solution is going to be water. I'm actually going to draw a picture of this to help you visualize. In fact, in chemistry class, you need to use your visualization skills to the best of your ability. Okay, so here's our cup, and it's a solution. So this is water, well, this is just liquid, liquid solution. And the liquid solution goes up to 200 grams, and we know it's an alcohol solution. But we know that approximately 180 milliliters is water. Okay, now the alcohol and the water are all dissolved. They're not separated like this, but I'm kind of drawing a little line to show that this is approximately around 180. It's an approximation. Okay, and we're trying to figure out what is the mass percent of the alcohol. So what's the alcohol remaining, which is in this spot right here. This area is a visual representation of the alcohol remaining. Okay, so 200 grams of the solution minus 180 grams of H2O will give us, this is the solution, the alcohol solution, will give us the alcohol in the solution. Oops, I said 188, not 180, my fault. Let's put 180. So we know that there's 20 grams of alcohol in the solution. Are we done? Is that our answer? No, that's not our answer. We need to figure out what the mass percent of the alcohol is. So we need to take the part, which is 20 grams of the alcohol, divided by the whole, which is a total of 200 grams in the solution. 200 grams of the solution. S for solution, we'll capitalize this A to make it easier. And A for the alcohol. Okay, and once we get that answer and we multiply by 100%, then we know the percent of alcohol. Oops, my fault if you weren't able to see that. The percent of alcohol in the solution. Okay, so since I know, quick math, since I know that 20 divided by 200 can be reduced to 10 divided by 100, well, that's what percentage is, part of 100. 10 divided by 100, so this is 10%. Okay. Next question. How many grams of this compound, NaBr, which is known as sodium bromide, are needed to make 50 grams of a 5.0% solution? Okay, we want to make a 5.0% solution of sodium bromide, which means that 5% of the solution will be the sodium bromide, and the total solution is going to be 50 grams. We want to make a 50-gram solution. So let's draw a picture again. Okay, so here's our picture. And we want to know, here's sodium bromide powder. Sodium bromide powder. We want to know how many grams of the sodium bromide powder we need to put inside of the solution in order to make sure that this total solution is a 5% solution of sodium bromide. Well, the rest will be water, because that's how you make a solution, is with water. Okay, we know that the total solution is going to be 50 grams of the S for solution. Okay, this is using your visualization skills. So if I want, this is an example of using your visualization skills, and it's good for you to do this in chemistry all year long. So if I wanted to do this, I'm trying to figure out what part of sodium bromide goes in here to make a 5% solution. So what I need to do is take my 50 grams of the solution, and I'm going to put that over the number 1. Okay, S, this is an S. I know it's weird. This is a 5. This is a 5. This is an S for solution. S for solution. Okay. Okay, and then I'm going to multiply by 5 and divide by 100. Why did I multiply the 50 times 5 divided by 100? Well, because the percentage means part of 100, and that's what I'm doing right here inside of this parentheses. Okay, so 50 times 5 what? What unit goes right here? Well, this would be 5 grams of the sodium bromide, and this would be 100 grams of the total solution. We'll say of a solution, yeah. So 50 times 5 divided by 100, that's the math that we need to do. Okay, so 50 times 5 is 250 divided by 100 equals 2.5. 2.5 grams of NABR. That's our answer. Did I get it right? Yes, I did. Okay. So students, you can also, this might be really easy math for you. That's fine. If it's not, follow the directions. You could also think about it like this. Percent means part of 100, right? So if there was 5 parts of 100 in sodium bromide, we want to know how many parts of sodium bromide go into 50. So if 5 was out of 100, how many would go out of 50? Well, exactly half, because 50 is exactly half of 100. And look what we have here. 2.5 is exactly half of 5. Okay, good. Basically, I'm gonna give you, these are challenging problems now. I'm gonna let you pause the video, and I'm not gonna work through the problems with you. I can give you the answer. Oh, there's the answer. And I'm gonna give you the questions and the answers, and we can talk about them in class when you have questions. Here we go. Next question, pause the video, giving the answer in 3, 2, 1. We'll talk about that one. Next question. Pause the video, giving the answer in 3, 2, 1. You can pause the video. Here's the next question. Pause the video so you can read it, you can attempt it, you can try it. Here's the answer in 3, 2, 1. There we go. Next question. Use your visualization skills, draw it out. You know what I mean? Draw these out. Draw them like I did. Here's the answer, 3, 2, 1. And is that it? Is that the final? Yep, that's it. That's the final one. Okay, that's your mass percent lecture. Bye.